We're moving through this thing called statistics, and now as we learn to talk about distributions, we know two things that we can talk about. We can talk about the shape. Is it skewed left, skewed right, symmetric, uniform, bimodal? And we can also talk about the center. Are we talking about the mean, or the median, or the mode? Well, it turns out that these two things are related, and so let's take a look at that right now. You know, we study statistics so that we can answer interesting questions, and a question that I'm very interested in is this one. How many penguins live in your basement? Why am I interested in this? Well, penguins are adorable, and they're cold weather friendly, and we live in cold weather, so it stands to reason that I think some of us should probably have a pretty decent number of penguins living in our basement, be it because we found one in the park by our house and we adopted it, took it in, or if the penguins just sort of like took up residency there and they're pests. Anyway, I asked my first hour how many penguins they had living in their basement, and one student said one, two students said two, three students said three, two said four, and one said five. Okay. Now, this is obviously a symmetric distribution. Okay. So let's look at the mean and the median of this guy. If I wanted to find the median, I'd say there are 1, 2, 3, 4, 5, 6, 7, 8, 9 values. If you have 9 values, you can break it up into, there's 1 in the middle, there's 4 on this side, and there's 4 on the other side. So I guess I'm looking for the 5th value. That would be our median. So 1, 2, 3, 4, 5. That would be the median right there, right? These 4 represent the lower half. These 4 represent the upper half. And so in this case, our median would be 3 penguins. Well, let's find the mean now. We would get the mean just by adding 1 plus 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4 plus 5, and then dividing by, there are 9 students that I interviewed. And if we do that, we will get that the mean is 3. So in the case of this symmetric distribution, the mean and the median are exactly equal to each other. And in fact, when you have a symmetric distribution, the mean might not always be equal to the median, but it should be pretty darn close. Let me mention that they were exactly equal in this case because this is exactly symmetric. All right. So I go to my second hour class and I ask them, how many penguins you got living in your basement? And they had some different answers. 3 of them said 2. 2 of them said 3. 2 of them said 4. 1 of them said 5. And then I had to extend my dot plot for them. 1 of them even said 6. So this time, if I want to find the median, same game, there are 9 of them. So I'm going to find the 5th value, 1, 2, 3, 4. The 5th one right there would be our median. Just check that that's right. These 4 below, these 4 above. So our median is 3. Now, what do you think is going to happen with the mean to this one? Is the mean this time going to be the same as the median? Well, if we did 2 plus 2 plus 2 plus 3 plus 3 plus 4 plus 4 plus 5 plus 6, notice that even though we have the same number of values as above, on average, they're a little bit larger, right? We don't have any 1s, and we've got like a 6 over here. So the mean ends up being 3.4. Now, if you look at this graph, you'll notice that it has this tail over here on the right. And if it has a tail on the right, we know that that means it is skewed to the right. And here's the big takeaway that I want you to have from today. When something is skewed to the right and you get that tail, by pulling on that tail, it pulls the mean with it, which is why for this skewed right distribution, the mean ended up being larger than the median. This is going to be one of our rules. In skewed right, mean grows larger than median. Okay. So my third hour class comes in, and I ask them the same question once again. I say, how many penguins do you have living in your basement? Can you believe that one of those kids has none? Poor dude. One of them is one of them is two. Two of them have three, and 1, 2, 3, 4 of them have four. None of them have five. Okay, so this time we have a distribution that is skewed to the left, or in other words, the tail is here on the left. Well, can you guess what's going to happen in the relationship between the mean and the median? Our median would be 1, 2, 3, 4, 5. Oh, it's still 3. But our mean, since we have more small values, our mean is going to end up being tinier. In this case, it ends up being 2.8, which means that the mean is smaller than the median. This should generally always be true with skewed left distributions. And once again, it's because when you pull on this tail here, when you pull the distribution to the left, it doesn't really affect the median, the middle, but it is going to pull the mean downwards. Oh, that's not the way you're moving. Downwards with it. Well, that brings us to kind of the point of all this, which is in your last section, you were learning about measures of center, but we didn't address this question. Which measure of center should you choose when you are describing a data set? And the answer to that question is it depends on the shape. So here are 3 rules to live by. If you have a distribution that is symmetric, with no outliers, then you're going to use the mean. Why the mean? Because it's kind of the standard. It's the thing that most people in the world understand. And if you can use something that people understand, you do it. Okay. However, if the distribution is skewed, you can't use the mean, because we now know that the mean gets pulled with that skew, and that distorts its value. Also, there's something else we learned in our last lessons, which is that outliers also pull on that mean. So if it's skewed or there are outliers present, you are going to use the median. Now, let's not leave out our friend the mode. There is a kind of rare case where you might choose to use the mode. And let's look at it. Let's suppose that, let's go back to penguins. Imagine we had 0, 1, 2, 3, 4, or 5. In my 4th hour class, 1, 2, 3, 4 students said 0. And 1, 2, 3, 4 students said 5. If you were to choose the mean or the median, in this case, they would both tell you about 2.5. But that's not a good measure. It's not a good measure at all. There are no students that have anywhere close to 2.5 penguins. What would I have a penguin look like? In their basement. So it makes more sense in this case to say, well, there's a mode at 0 and a mode at 5. And what kind of graph is this? This is bimodal. So if bimodal, then you're going to use our friend, the mode.